Guys, let's do this problem right here. The question is asking to solve the system and they have given three equations. Let's see how we can do this. So first of all, I have to bring this one into matrix form. So it's going to become 2 minus 1, 3, 1, 2, 2, and we have 1 minus 3, 1. And the other side we have 0, 0, 0. So let's see, 2 minus 1, 3, 1, 2, 2, and 1 minus 3, 1. So we copy that, right? And in this case, the best method to do is Gauss Jordan, because that's gonna directly give the answers to this kind of question. So let's do the Gauss Jordan. To do that one, the first thing we can do is we can swap the simplest form with the first value, because whenever we bring the simplest value on top, everything will become easier. And let's do this one first. 1 minus 3, 1 is going to be on top. I am swapping the third equation with the first equation, so 1 minus 3, 1 is on top right now. Then 1, 2, 2, 0. Then we have 2 minus 1, 3 on the bottom. Then what I can do is I have to eliminate, I have to bring the pattern 1 0 0 0 0 1 0 0 0 1. So to do that, I have to eliminate this one, these two values. I have to bring this into 0, right? So in order to do that, what I have to do, I have to multiply the first equation by -2 and add it with the third equation. Or you can multiply the second equation by -2 and add it with the third equation. It doesn't matter which equation you choose. I'm choosing the first one. So let's see. 1 minus 3, 1, 0, and 1, 2, 2, 0. And if I multiply the first equation by -2, it's going to be -2 r2 r1 plus r3. So if I do that, this will become 0, and this will become positive 6 plus -1 is going to be 5. And here we get -2 plus 3 is going to be 1, and other side is going to be 0. And let's continue in the other side. So we have 1 minus 3, 1, 1, 0. Now I can eliminate the second equation, second column, second row first column, by simply multiplying by first equation by -1 and adding with the second equation. So if I do that, let's see what happens. So negative r1 plus r2 is going to give me 0 in the first column. Then we have minus 3 is going to be plus 3, plus 3 plus 2 is going to be 5. Then we have 1. So if I do minus 1 plus 2 is going to be 1, equal to 0, and 0's 5, 1. Now it's very obvious that second and third are same, therefore I can eliminate one of them by multiplying one of them by -1 and adding with the other one. So let's see, I can, if I eliminate the third one, everything will become easier. So let's multiply the second one and add it with the third one. So the equation is going to be 1 minus 3, 1, 0. Then we have 0, 5, 1, 0, and I'm multiplying the second equation by -1 and adding it with the third equation, which is going to give me 0, 0, 0. Now from this one we know this solution is going to be infinitely many, because we have a solution with 0, 0. It means like we are going to have a free variables and stuff like that, right? So in this case, but I'm not done yet. It's better to, you can go ahead and you do x minus 3y plus c is equal to 0 form equation and solve it, or you can directly do the Gauss Jordan in the full form, and that will give you the answer too. So I would like to do everything in the Gauss Jordan and bring the final solution. So let's go further and do this one. So it's going to be -1 minus 3, 1, 0, and to bring this into simplest form, I can divide this one by 5, and if I divide this one by 5, it's going to become 1, and this is going to become 1 over 5, and the other side we are going to have 0, and in the bottom it's going to be 0, 0, 0. And now I can eliminate the first whatever the value above p. So we have to have whatever the value above p vector equal to 0. So in this case, therefore I have to eliminate the -3 right here. So to eliminate, I can multiply the second equation by 3 and add it to the first equation. So if I do that, let's see what happens. So if I multiply the second equation by 3, it's going to be 3r2 plus r1, which is going to give me 1, 0. Then we are going to have 3 over, like if I multiply the second equation, it's going to be 3 over 5, 3 over 5 plus 1 basically means 5 over 5, so 5 over 5 plus 3 over 5 is going to be 8 over 5. So here we are going to have 0, 1, 1 over 5, and the other side is going to be just 0, 0, 0. Now we have brought it into Gauss-Jordan pattern. Now we can go ahead and write in terms of free variable. First of all, we have to know what is free variable is. Free variable is whatever the value that doesn't have pivots, whatever the column that doesn't have pivots. So in this case, we have first column have a pivot, that's with this one, and second column has a pivot, the right here. The third column doesn't have a pivot, therefore that's going to be my free variable. If I do x, y, z, and in the question they have given in x1, x2, x3, so it's better we have to bring it in that form. So the first column x1 has pivot, x2 has pivot, x3 doesn't have pivot, therefore x3 is my free variable. So this is my free variable, therefore I have to write everything in terms of free variable. So first of all, let's form the equations. In this case, the first equation is going to be x1 plus 8 over 5 x3 is equal to 0. The second equation we are going to form is x2 plus 1 over 5 x3 is equal to 0. Now I have to bring this into in terms of free variable. So x1 is going to be equal to minus 8 over 5 x3, and x2 is going to be equal to minus 1 over 5 x3, and x3 is going to be itself because it's a free variable. Now we have to arrange it in this form. So it's going to be minus 8 over 5 x3 comma minus 1 over 5 x3, and x3 is going to be itself, it's going to be just x3. That's my final answer, and this is the solution for this system. I hope you guys like this video. See you next time.